All right, here we go. Here is your homework. There are 8 problems today. Okay. Last section of the chapter is called Locus and Constructions. So we're actually going to do some literal constructions today with the compass, the protractor, and we're going to do a locus problem. Let's see. First day we did locus problems. We did 4 problems. The second day, Loci problems, we did 2, and guess what? Follow that pattern, 4, 2. We're going to do 1 problem today, and that's it. All right, just 1 problem today, and here it is. So this is a Loci problem or loci problem. You are given 3 things there. You're given angle N and 2 segment lengths there, and you're going to ask to do the following 4 conditions. And the 4 conditions are, I got to make a triangle. The triangle has to be ABC. Angle A of said triangle needs to be N degrees. The length of AB needs to be R. And the altitude to AB has to be of length S. So the answer is going to be what we wind up with. What we wind up with is triangle ABC. Well, yeah, I just can't say that. I actually have to do this construction. So that's the goal of today. So I'm going to go ahead and switch on the document camera, and let's do this one. Now you can pause it, and you can just make, if you want to do this yourself, make N approximately 45. It can be anywhere, any acute angle, just make it about 45 degrees, and give me 2 segments that aren't the same distance, R and S. All right, go ahead and pause that, and then come back, and I will set up the document camera. Okay, here we go. So there's my angle N, there's my length R, and there's my length S. Notice that R does not equal S. And over here, these are the 4 conditions I need to make happen here. I need to make a triangle ABC. Angle A has to be N degrees. AB has to be R. And that's ALT, altitude. The altitude to side AB of the triangle has to be equal to S. Now, with those 4 conditions, I can't make the triangle to start with. I got to start off with one of those 3 conditions right there. Our angle A has to be N degrees, AB has to be R, or the altitude. And of those 3, either the measurement of angle A or the length of AB would be the 2 easiest things to start with. It doesn't really matter. I'm gonna start with this one right here. I'm gonna start with side AB needs to be length RY because it's sitting right here. So let's see, well, this is supposed to be construction, so we got to do the construction. So the first step is to make side length AB. So if this is A, right here, B is going to be somewhere down here, and the length of AB is going to be equal to R. So this is literally construction 1A, make a congruent segment. So let's see, I'm going to go to R. I'm going to put the point there on one end, open up my compass to length R. Now, sometimes when I do this, I'll draw a little arc just so I can, yep, that's accurate. And then transfer that to here. I'm going to the left edge of A, draw my arc. And then what I can do is I can put my dot right here. Remember, I always measure from the left edge of the left dot to the right edge of the right dot. So I notice I'm making this dot pretty big. So that's my AB. And I mean, I don't have to erase things. I can leave it that way. But there's one side of the triangle. There's triangle or side length AB. All right, so let's see. This condition right here, this is complete. I got 3 more conditions to do. The next easy one would be, let's make the measure of angle. If this is A, and it's going to be of a measurement N, well, N is sitting right here. I just need to make this angle appear right here. So remember that construction? Step number 1, we're just going to copy the angle over. So step number 1 is open up your compass so that you can get an arc to appear on the given angle. So, whoops, I'm not taking my own advice of putting the pressure on the pointy part. So there's my arc, and I'm going to make that arc appear right here. So it needs to look the same way. When in doubt, just make it larger. And by large, I mean like more of the circle. I'm not doing too well with my pointy part today. And notice now my arc is larger than that, or I shouldn't say larger. My arc goes further around. That just keeps me from ever, making a silly mistake of, like, if you make it too short, the arc, and then you try to do the next step and you don't have enough room. So if you make it larger on the one that's trying to draw, you'll never run into that problem. Okay. Step number 3 of making a congruent angle, I'm going to measure this intersection to this intersection with my compass from here to here. Okay, so there's the point. I talked to you today at play practice, and you said you had a good compass. So there's that. You don't need to make that arc right there. I always make it just so that I can see for sure I've got the right measurement. And then I'm gonna place that here. I'm not changing the distance. And notice I made my arc way too large, but that's okay. All right. Last step of making a congruent angle is to go through that intersection point. And I don't know how far to go, so I'm going to draw it a pretty good distance. So there's my second, well, I don't really know. I mean, it is going to eventually be the second side of the triangle. I just don't know how long it's going to be. All right, so we just made that one right there, 2 down, 2 to go. As always, it turns out that the last part is there's 2 left, but as soon as we get the third side, then we'll have triangle ABC. So I really only have one other condition, and that is the altitude to AB has to be of length S. And let me see if I can demonstrate the problem right here. So I'm just going to draw a generic triangle ABC, right? So same basic one I'm making right there. I don't know where C is up here. And the problem is that if you draw the altitude, remember the definition of the altitude is the distance from the vertex, so vertex C perpendicularly down, and this length right here is going to be of length S. And that's what I have to construct up here. The problem is, notice this is at an angle. I just don't know I don't know what this angle is right there. So we're going to have to do some thinking. So how am I going to make that perpendicular? Because I don't know where this point is right there. I mean, maybe it's at B, maybe it goes straight up, maybe it's somewhere here in the middle. I just don't know. So how am I going to do this? And this is a very challenging one. I would ask for you to pause the video and give it a good, I don't know, 3-4 minutes of thought, and then come back and we'll discuss it. Okay, so here is the answer. So the answer to it is, well, I know this has to be perpendicular. And I know if I extend this line right here, I can draw another perpendicular for, if I say for that point, I can certainly make another perpendicular. Why is that useful? Because then I can measure this distance from here to here, and make it length of S. And then extend this a little bit further. So there's length S. And then I can make another perpendicular. So another right angle right here, and extend this over, and wherever this will intersect, that's where I want point, or that's where I'm going to want my point C to be. So that's what I'm going to do. All right, play that again a couple times. Make sure that makes sense. All right, to execute that, here's what we do. So I just need to extend AB a little bit further, okay? Because what I'm going to try to do is I'm going to make a perpendicular right there. Now, could I make a perpendicular from B? Sure. I'm going to make it over here just so it's out of the way from the triangle, my eventual triangle. Some would argue just do it from point B, and I would agree. You can do that. So my goal here is to make a perpendicular. So we're making a perpendicular through a point on a line. Remember that construction. Boy, we're already up to the third construction. Is that you open up to any distance as long as it fits, and you make an arc to the right, and you make an arc to the left of the point you want your perpendicular to go through. So I made an arc to the right and an arc to the left. Then I'm going to open this up to more than halfway. It doesn't really matter as long as it's more than half. You can put arcs below or above. I'm going to go with above, and I'm going to go from this arc intersection and this arc intersection, and I'll make arcs appear above the point. So I'm just making a perpendicular through that point. So arc above, not changing the distance, arc above. Okay. And then all I have to do is extend this through the point, through the intersection, and extend it all the way up there. Okay. Now looking back here, I need to make this distance up here the distance of S. So construction number 4. Now, we've already done this construction before, so it's not a different type of construction, just a second version. So that's the length of S, and I'm going to measure that. Oh, no, I'm going to have some problems here because my arcs are kind of flowing together now. So that distance right there is S. Okay. So this point right here, I'm going to make a nice big dot. And now what I need to do is turn it sideways and make another perpendicular through this point. And that way it would go here and there. If I drop a line straight down, I'm making basically a rectangle here, and opposite sides are both parallel and congruent. So I'm going to make a perpendicular through this point right here. So once again, open it up to any distance you like. I need an arc to the right and to the left, and I'm getting a lot of arcs here, so make sure your arcs are away from the other ones so you don't confuse yourself. Okay, so I got an arc left and right. Then I'm going to open it up to a distance, and where do I want more than half? So do I want my arcs to go over here, over here? It doesn't really matter. I'm going to put them over here so they're out of the way so when I make my triangle. So let's see. Other people might argue that's to put it in the middle. It doesn't. It's just an argument. There's no right answer here. Further away actually is a bit more accurate. Notice I didn't go through it. I didn't make my first arc long enough. There it is. Okay. And now here's what I'm going to do. I'm going to go through this intersection, through that point, but I don't really need to draw this part of it. I need to draw this part of it. Okay. So I've just now made a perpendicular. Well, let's see. This was perpendicular. This was perpendicular. That means these two lines are now parallel. That means anywhere along this point right here is going to be linked S, right? And then all I have to do now, oh my gosh, got to do another perpendicular, is from this point right here, because this is going to be C. If I want to make the altitude, which I'm not going to do, then I could drop a perpendicular straight down. I'm gonna freehand this one. Just this would not be part of the construction, but this would be the altitude. I'll draw a dotted line. Right. So I think you could agree you could make it perpendicular straight down. And notice, since I just made a rectangle here, then if this is S, I'm sorry, if that's S, then the opposite side is also S. But our goal was to make the triangle, so all we now need to do is connect point C to point B, and voila, there we go. There is triangle ABC. Oh, there's a lot of stuff going on here. There's triangle ABC that has an angle measurement where angle A is equal to n degrees. We did that construction. Side length AB is equal to R, which we made. And the altitude to side AB, so that's from C to AB, is equal to S. And now we have all of those, and that's the construction. So will all the ones for homework take this long? No, they're not as complicated as this one. I want to do one that had a bunch of, even though it looks like it has 4 conditions, all you do is 3 of the conditions, and the 4th one just comes along for free because it's triangle ABC. All right, so there is your low-key problem right there with a construction. Good luck on your homework. And this is the last section, so we'll do a chapter review after this. I'll just go ahead and talk about it real quick. So the chapter test is going to be 10, or is it 11? It's either 10 or 11 of the total constructions. So we did, counting 1A and 1B, we did 15 constructions. And then I'll have a couple of the centroid problems. Do you remember centroid? Centroid is where you have the triangle and you have the medians, and so that connects to the middle of the 3 sides. So middle, middle, middle. And remember, that breaks it up into 1/3, 2/3. And then you can do some formula work there to find distances. So I have a couple problems on that, centroid. And then we'll have 10 or 11 constructions on the test. That'll be the test. So tomorrow or next class we do, I'll do a full review. I'll do all 15 constructions once. And it's good practice. And then I'll just pick, 11 of them or 10 of them at random and a couple centroid problems. And that'll be the next class. And with that, that'll be it for today. And I'll see you next class.